we are going to see machine learning inspired codeword selection for dual connectivity in 5G user-centric ultra-dense networks. Introduction. The rise in mobile user demand necessitates high network connectivity, leading to the introduction of 5G networks. Dual connectivity handles data rates and spectrum, but rapid access requires a large number of base stations and users. To enhance network performance, machine learning is used to identify code words in mobile requests, enabling optimal base station selection. The selected base station handles the request and sends a response back to the client. Objective of the project. The project focuses on selecting code word base stations in 5G dual connectivity using 3 modules. The first involves random distribution of base stations using Poisson point processes, while the second uses probabilities of macro cell BS or small cell BS and derive the average sum rate. The third module uses an iterative SVM classifier and sequential minimal optimization SMO algorithm for codeword selection. The iterative SVM-SMO classification, that is ISSC algorithm, achieves highly efficient performance in DC. The project uses a 5G dual connectivity network dataset with training samples and labels and combines SVM and SMO for good classification results. Requirements. To execute this project, these are the requirements needed. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Upload 5G Beam Selection Dataset. Using this module, we will upload 5G Beam Selection Dataset. The second module is Preprocessed Dataset. Using this module, we will remove empty values and then split dataset into train and test sets. SVM SMO get trained on trained data and its ASR will be calculated using test data. The next module is Run Average Sum Rate Algorithm. Using this module, we will classify code words based on channel estimation using normal SVM algorithm and calculate ASR rate. The next module is Run Proposed ISSC algorithm. Using this module, we will train SVM SMO and then calculate correct classification rate from test data. The last module is ASR Comparison Graph. Using this module, we will plot a graph comparing performance of ASR based algorithm and ISSR algorithm. Execution of the project. To execute this project, first we have to open the code folder. This is the dataset folder in which I have the required dataset. Open the dataset folder. This is the text document in which I have the link for a link to download this dataset, and this is the dataset. Open the dataset. First row contains signal names and last column contains class as code words and remaining rows contain signal features. Each row associated with one class label as code words. SVM SMO get trained on this signal features and class label, and whenever new signal features arrive, then SVM will predict code word. If we scroll down, we can see 46, 120, 106, 34, etc. These are the code words to identify base station and remaining are signal features. Close this window, and this is the model folder in which I have the pickle file stored, which contains the algorithm information. These pickle files can be loaded into the project code during runtime to utilize the trained models. These are the Python main code files. This is the run.bat file. Instead of executing the program in project in command line interface, we have created the Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. Now click on Upload 5G Beam Selection Dataset. A dialog box will be opened. Select the dataset and click on Open. In this graph, we can see total code words for beam selection available in dataset. Close this graph, and in the text box we can see the confirmation that the dataset is loaded, and these are the top 5 rows of the data, and the dataset contains 31 columns. Now click on Preprocessed Dataset. So in the text box we can see the dataset contains total 500 records and each record contains 30 signal features. And application is using only 400 records to train and 100 records for testing. Now click on Run Average Sum Rate Algorithm. So we can see that with existing ASR algorithm, we got correct classification rate as 0.78%. Now click on Run Proposed ISSC algorithm. So with the proposed ISSC algorithm, we got correct classification result as 0.97%, which is better than existing channel estimation ASR algorithm. Now click on ASR comparison graph. So in this graph, x-axis represents algorithm name and y-axis represents ASR values, and in both algorithms, proposed ISSC is giving better ASR correct classification rate. Close this graph, and the conclusion here is the project presents 3 modules for selecting code word based stations in 5G dual connectivity. The first uses point processor for random distribution, while the second uses macro cell BS or small cell BS probabilities for average sum rate ASR in UUDN. The third module uses an iterative SVM classifier and sequential minimal optimization algorithm to efficient code word selection, with ISSC outperforming ASR correct classification rate.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.